Everyone, welcome to my YouTube channel Civil Square Insights. In this video I am going to solve 2023 JLEE paper civil engineering portion. In this video I will solve 25 questions with detailed analysis, and in the next video I will solve the remaining question. So previously I have solved 2024 paper. So if you have not watched, you can now watch by clicking the link given in the description box. So one request, if you have not subscribed my channel, please subscribe my channel. So let us begin with the first question. That is, on any good staircase, the maximum and minimum piece respectively. So what is piece? So piece is nothing but the angle made by the nosing line with the horizontal, right? So what is nosing line? Notice nosing line is the so let us understand what is nosing lines. These are horizontal and these are nosing lines. Okay, so these are step. This is our trade portion. This is our trade portion and this is our riser portion, right? So all the this is our additional projection, right? So the external projection that come out, that is called nose, right? Nosing. So if I connect the nosing points, all the nosing points, that imaginary line that connect the nosing point is called our nosing line. Okay, so this nosing line made some angle with the horizontal, right? This angle is called our pitch. Okay, so for the maximum and minimum piece, that is our 25 to 40 degree. Okay, 25 to 40 degree. So here in the option, that is our 45 to 25 degree. Okay. Okay, 2-3 important points I want to mention. Minimum width of landing. Minimum width of landing is taken to be the equal width of staircase. Okay, equal width of stair. Remember, this is important. Minimum width of landing hole equal width of stair. মানে stair যিমান width থাকিব সিমান হ'ব মানে minimum width of landing. Minimum আমি তাতকৈ বেছিও দিব পাৰোঁ, কিন্তু মিনিমাম দিব লাগিব কিমান stairৰ widthৰ সমান. ওকে, তো জেনেৰেলি আমি কিমান লওঁ 80 সেন্টিমিটাৰকৈ লওঁ. মনত থাকিব, ডেট ইজ আৱাৰ 80 সেন্টিমিটাৰ. জেনেৰেলি 80 সেন্টিমিটাৰকৈ লওঁ, 80 সেন্টিমিটাৰ বা 90 সেন্টিমিটাৰ. ওকে, 90 সেন্টিমিটাৰ. ৰেচিডেঞ্চিয়েল বিল্ডিঙৰ কাৰণে 90 সেন্টিমিটাৰ. ওকে, মনত ৰাখিব 90 সেন্টিমিটাৰ পইণ্ট মিটাৰ. আৰু পাব্লিক বিল্ডিঙৰ কাৰণে 1.2 মিটাৰ. ওকে, 1.2 পৰা 1.8 মিটাৰ. আৰু নাম্বাৰ অফ ষ্টেপ in one flight, number of stay in one flight minimum 3 and maximum kiman? Maximum 12. Okay, remember. Okay, coming to the next question. Two separate walls in a cavity wall are called as. So first of all, what is a cavity wall? So cavity wall to all amar enokata wall zero duta parallel level যেটো দুটা ওয়ালে দি বনাও, আমি দুটা ওয়াল কনস্ট্রাক্ট কৰোঁ, মাজত কি ৰাখোঁ আমি স্পেচ, মাজত খালী স্পেচ ৰাখোঁ, ডেট ইজ আৱাৰ এয়াৰ স্পেচ বুলি কওঁ আমি, বা কেভিটি বুলি কওঁ. চ' দুটা পেৰেলেল ৱাল থাকে, মাজত স্পেচ থাকে বা কেভিটি থাকে, ডেট ইজ কল আৱাৰ কেভিটি ৱাল. কেভিটি ৱাল আমি কি কনষ্ট্ৰাক্ট কৰোঁ? ফাৰ্ষ্ট অফ অল ডেমনেছ প্ৰিভেণ্ট কৰাৰ কাৰণে ডেমনেছ, হিট ইনচুলেশ্যন আৰু সাউণ্ড ইনচুলেশ্যন. ওকে, এটা কেভিটি হ'লে মিনিমাম উইথ কিমান? মিনিমাম উইথ শুড নট বি লেছ দেন 10 সেন্টিমিটাৰ. ওকে, আৰু মাজৰ যিটো কেভিটি থাকিব, মাজৰ কেভিটিৰ যিটো উইথ মিনিমাম উইথ 5 সেন্টিমিটাৰ. ওকে, ইট শুড নট বি লেছ দেন 5 সেন্টিমিটাৰ. ওকে, নাও these two wall that constructed is called outer wall. This is our outer wall or inner wall, and this is our inner wall. Okay, if this is the outer wall, this is called inner wall. So this outer or inner wall is also called lips. Okay, leaves. Okay, this is also called as leaves. Okay, and also called as this outer lip, and this is our inner lip, and these two can also be termed as skins. Okay, important. So the answer is both B and C. Okay, now coming to the next question, the process of fixing intermediate points are known as, so intermediate points are known as ranging, right? Coming to the next question, the RL of the point A which is on the floor is 103.5 meters, and the backside reading on A is 1.950 meters. If the foresight reading on the point B which is on the ceiling is 2.350 meters, the RL of point B will be. So let us do this question. So consider this is our ground, right? This is our floor. So there is a point, so here is our instrument. Okay, this is point is the point A is which is on the floor, right? This is our point A. This is our point A which is on the floor. The RL of point A is given, that is our 1.103.5. Okay, this is RL. RL of A is given. Now the height of ceiling is also, the back side of the ceiling is also given, right? Foresight of the ceiling is also given. Now this back side is, this reading is taken, backside reading on A, right? Backside reading is taken, that is our 1.950. 1.950. This reading is 1.950, right? Now here the reading that was taken on ceiling was this is our staff, right? So here the reading was found to be 2.350. Okay, if the foresight reading on the point B which is on the ceiling is 2.350, these are 2.350. Okay, this reading, in this case here this staff is inverted. Okay, inverted. When we are measuring ceiling height, we invert the staff. Okay, inverted. Okay, now this here is our, this is our instrument, right? This is our instrument, right? So here the height of instrument will be this RL. Here from here to this is our mean sea level, right? From mean sea level to point A, this is our RL of point A, right? Now if I want to measure the height of instrument, so RL of point A plus, so this will be our height of instrument, right? This is will be our height of instrument. Okay, so RL of point A 103.5 plus this value, right? 1.950. 1.950 will be the height of instrument. That is our 105.45 okay meter. This is our height of instrument. Now we need to find the value of what? The RL of the point B. This value we need to find, right? This value we need to find. How will I find that? So height of instrument is equal RL plus backside or foresight, right? So here I want to find RL. So RL is equal height of instrument minus backside or foresight. So foresight. So height of instrument is found to be 105.45 minus foresight. What is the foresight of ceiling? That is our 2.350. 2.350. But here the staff is inverted, so minus 2.350. So that is our plus. Okay, 105.45 plus 2.350. 0.35. The answer will be 107.8 meter. Okay, so the answer will be 107.8. Option B is the right answer. Understood? Coming to the next question, the most reliable estimate is detail estimate, right? Detail is the most accurate estimate. Okay. Now central line method is specially used for estimating. Central line method is used for estimating what? Symmetrical building, right? Symmetrical cross section. If the building has symmetrical cross section or symmetrical walls, then we apply central line method, because central line method is normal method, is easier method. And if the building is symmetrical or the wall is symmetrical, and then it will be easier to estimate the building using the central line method. Okay, so circular building, octagonal, so all of the above. So in central line method, the quantity is equal to total central line into width into depth. Okay, it is a quick method. Okay, and here when there is junction, some deduction is required. So if there is a L junction, if there is a L joint, no deduction is met. Okay, no deduction is met. If there is T junction, W/2 is deduct. Okay, W/2 here, W means width of the wall. Okay, if there is a cross section junction, then full width of the wall is deducted. Okay, W is deducted. That is our full width. Okay, full width of wall. Okay, remember these things are important. Logan-Shortall method. There is another method that is called Logan-Shortall method. Logan-Shortall method is used in PWD. Remember, Logan-Shortall method is used in PWD. Damp-proof course TPC is measured in. Damp-proof course DPC, right? One thing, damp-proof course always measure in ordinary residential building, damp-proof course or public building, damp-proof course is provided at plinth level. Remember, at plinth level. Okay, and thickness of DPC 40 mm, right? Minimum 40 mm. Okay, and if I talk about the mixer, concrete mixer, if we provide RCC DPC, then RCC mixer will be 1:2:4. Okay, and if you provide lime mortar, then it is 1:2. Okay, if you provide okay, these things are important. And also DPC can be vertical or horizontal. Okay, and there are materials that we provide as DPC material. So what are the material? So semi-rigid material. First of all, flexible material. So flexible material comes under plastic sheet, bituminous felt, these important things. Okay, bituminous felt, these comes under flexible materials. Okay, and semi-rigid material. Semi-rigid materials, example, mastic asphalt, okay, mastic asphalt. Rigid material, cement, concrete, stone. These are called rigid material. Okay. So one thing you should remember, that is the most common thing that we used as DPC material, that is our bitumen. Okay. Okay, coming to the next question. Capillary fringe water is also called our headless water. Okay. Capillary fringe water is also called headless water. So capillary water means when we irrigate water, when we irrigate to a crop, suppose this is our crops, right? These are crops. So when we this is the roots. Okay, this is the root zone. Okay, so when you irrigate to a crop, then a small amount of water pass the root zone, right? When the water percolates to a greater depth, then it is called gravity water. Okay, this water is not available for the plant, right? It percolates very depth. That is called our gravity water. That percolates under gravity. Okay, it goes beyond the root zone. Okay, it goes beyond the root zone depth. Okay, that is our gravity water. And some water is available in the root zone, that is called our capillary water. Okay, this capillary water is the water that is available for the crop. Okay, and there are some water which is also attached in that portion, that is called our hygroscopic water. And this hygroscopic water is not available for the crop. It cannot because it is held very tightly with the soil particles, right? So that's why the plants cannot extract this water. That is called our hygroscopic water. Okay, and this capillary water is also called as feathers water. Remember. And one thing, if the water is not available, if the water is not available to extract for the plant, then we call it as wilting point. Okay, so if the water is available at a certain limit or certain point that the plant cannot extract, then we call it as under wilting point. Okay, the water is under wilting point. Okay, then the plant will die if the water is under wilting point. If you don't irrigate, then the plant will die. Okay. Now coming to the next question, a current meter is used to measure the velocity of flow of water in OCF. Okay, in open channel flow. Okay. Now let us see some device or measurement device. Let us see some measurement device. First of all, some important measurement device. Okay, these are very important. Let us see one by one. So that is our first of all is hot wire anemometer. Hot wire anemometer. Number 2, pitot tube. Number 3, current meter. Number 4, sensory meter. Number 5, flow nozzle. Number 6, orifice meter. Number 7, band meter. Number 8, rotatometer. Sensory flume. also elbow meter. Okay, these things you should remember. Okay, here from flow nozzle to elbow meter, this all these devices are measured, are used to measure rate of flow. Okay, or discharge rate of flow. Okay, tensiometer is used to measure discharge, right? Current meter, pitot tube and hot wire anemometer, these are used to measure velocity. Okay, but here eventually current meter is used to measure open channel velocity. Okay, this was open channel velocity, open channel flow. And hot wire anemometer is used to measure gas velocity. Okay, gas velocity. So you should remember these devices because in exams these things we see. So coming to the next question, the yield line theory is there is a ultimate design approach for slab. Okay, so this yield line theory is also called upper bound method of analysis of under reinforced slab. Okay, option C is the correct answer. Okay, coming to the next question, in two-way slab, the limiting deflection of the slab is the limiting deflection of the slab is we know whatever the calculation we do, we calculate in terms of shorter span, right? So whatever the calculation we do in the design of slab, we calculate it in terms of shorter span. Okay, so we take shorter span for calculation purpose, right? So as per this option or C answer. Okay, the limiting percentage of longitudinal reinforcement in a coulomb is 0.8 to 6%, right? So coming to the next question, Darcy's law is valid for only laminar flow, right? So Darcy's flow is valid for only laminar flow. What is the Darcy's flow? So Darcy's flow, according to Darcy's flow, V is equal K, right? V is equal KIA. Okay, so Darcy's flow is valid only for laminar flow. Okay, so coming to the next question, which one of the flowing shear test is developed based on drainage condition? So based on drainage condition, shear test that is developed, that is our triaxial test, right? Triaxial test. Okay, so based on drainage condition, there are three types of triaxial test. There is our UU, undrained, unconsolidated, undrained test. Okay, unconsolidated, undrained. CD, consolidated, drain. And the another one is, that is our another one is consolidated undrained test. Okay, that is our consolidated undrained test. So what does it mean? So what is unconsolidated undrained test? So when the drainage is not allowed during the test, that is called unconsolidated undrained test. Okay, so this consolidated consolidated undrained test means a drainage allowed in the initial stage, but the drainage is not allowed in the final stage. Okay, but here consolidated drain test means drainage is allowed through the whole test. Okay, so it means the drainage is allowed during the test. So if the drainage is permitted through the triaxial test, we call it as consolidated drain test. Okay, drainage is allowed all the time. Okay, so from shear test we know we see some things. It's our direct shear test. First of all, direct shear test. Direct shear test is used for non-cohesive soil. Okay, non-cohesive soil. Remember, these things are important. Non-cohesive soil, drain condition. Okay, non-cohesive soil, drain condition. And another one is vein shear test. This vein shear test is used for cohesive soil. For cohesive soil and drain condition. Okay, undrain condition. Undrain. And the above is drain. And there is another test. There is our plate load test. Plate load test. Plate load test is used for calculation of ultimate bearing capacity, right? Ultimate bearing capacity. Okay, to calculate ultimate bearing capacity, we test plate load test. Okay, these things are important. Okay, coming to the next question. The main principle of an organization is delegation of authority, unity of command, effective control of at all levels. So option D is correct answer. For a flat control reservoir, the effective storage is equal to. So for flat control reservoir, so effective stress is used to control the flat, right? Control the flat. So here effective storage is equal to the storage capacity of the reservoir minus necessarily valley storage, right? Okay, during flood, the reservoir can have how much capacity of storage minus valley storage. Okay, that is called our effective storage, right? So the answer is option A. So useful storage and plus surcharge storage minus option B is correct answer. So useful storage plus surcharge storage minus valley storage. So here useful storage means the volume of water যেটো আমি রিলিজ কৰিব পাৰো ডিউৰিং ফ্লাইটত কিমানখিনি ভলিউম অফ ৱাটাৰ আমি ৰিলিজ কৰিব পাৰো ৰিজাৰ্ভাৰৰ পৰা, দ্যাট ইজ আৱাৰ ইউজফুল ষ্ট'ৰেজ। এণ্ড চাৰ্জাৰ ষ্ট'ৰেজটো হ'ল আমাৰ যিটো এডিশ্যনেল ভলিউম অফ ৱাটাৰ যিটো আমি কি কৰিব পাৰোঁ টেম্পৰাৰী কাৰণে ষ্ট'ৰ কৰিব পাৰোঁ, ৰাইট? টেম্পৰাৰী সময়ৰ কাৰণে ষ্ট'ৰ কৰিব পাৰোঁ ডিউৰিং ফ্লাড, দ্যাট ইজ আৱাৰ চাৰ্জাৰ ষ্ট'ৰেজ। চ' এই দুটা ষ্ট'ৰেজ প্লাছ কৰাৰ পিছত যদি আমি ভেলি ষ্ট'ৰেজটো মাইনাছ কৰোঁ তেতিয়াহ'লে আমি কি কৰিম, তেতিয়াহ'লে আমাৰ কি আহিব, আমাৰ ইফেক্টিভ ষ্ট'ৰেজ আহিব, ৰাইট? ভেলি ষ্ট'ৰেজটো হ'ল আমাৰ যিটো ভলিউমৰ ৱাটাৰ অলৰেডি নেচাৰেল ৰিভাৰত যিটো ষ্ট'ৰ হৈ আছে, চ' সেইটো হ'ল আমাৰ ভেলি ষ্ট'ৰেজ, ৰাইট? চ' ইউজফুল ষ্ট'ৰেজ প্লাছ চাৰ্জাৰ ষ্ট'ৰেজৰ পৰা যদি ভেলি ষ্ট'ৰেজ যদি মাইনাছ কৰি দিওঁ তেতিয়াহ'লে আমি কি পাম, ইফেক্টিভ ষ্ট'ৰেজ। অ'কে, চ' কামিং টু দ্য নেক্সট কুৱেশ্যন। Soil conservation means prevention of spread of desert, to check soil erosion by wind and rains, to check soil erosion by afforestation. So the option D is the right answer. Okay, the effective length of a batten start effectively held in position at both ends but not restrained in direction is taken as same length, right? So one thing মানে ইফেক্টিভলি হেল্ড যদি আমাৰ কুলামটো যদি ইফেক্টিভলি হেল্ড ইন পজিশ্যন থাকে বহুত এণ্ডত, আৰু যদি ৰিষ্টেণ্ড এগেইন ৰ'টেশ্যন, ৰিষ্টেণ্ড এগেইন ডিৰেকশ্যন মানে ৰিষ্টেণ্ড এগেইন ৰ'টেশ্যন, অ'কে? তাৰমানে ইফেক্টিভলি হেল্ড ইন পজিশ্যন বহুত এণ্ডত ইফেক্টিভলি হেল্ড ইন পজিশ্যন আছে, আৰু ৰিষ্টেণ্ড এগেইন ৰ'টেশ্যন মানে ৰ'টেশ্যন বা ডিৰেকশ্যনত কি কৰা আছে, ৰিষ্টেণ্ড কৰা আছে, ৰাইট? চ' ডেট ইজ কল্ড আৱাৰ এল। চ' এইটো আমাৰ হেৰি পিন জইণ্টৰ নিচিনা। চ' another point, যদি ইফেক্টিভলি হেল্ড ইন পজিশ্যন এণ্ড ৰিষ্টেণ্ড এগেইনষ্ট ৰ'টেশ্যন এট বোথ দ্য এণ্ড, যদি বোথ দ্য ইফেক্টিভলি হেল্ড ইন পজিশ্যন থাকে আৰু বোথ দ্য এণ্ডত যদি ৰেষ্ট্ৰিক্টেড থাকে তেতিয়াহ'লে তাৰ ভেলুটো কিমান হ'ব, 0.65 অফ এল, মনত ৰাখিব 0.65 অফ এল। আৰু যদি দুইটা এণ্ডত যদি ইফেক্টিভলি হেল্ড ইন পজিশ্যন থাকে আৰু যদি এটা এণ্ডত যদি ৰেষ্ট্ৰিক্টেড থাকে, এটা এণ্ডত যদি ৰ'টেশ্যন ৰেষ্ট্ৰিক্টেড থাকে তেতিয়াহ'লে তাৰ ভেলুটো কিমান হ'ব 0.8L। যদি এটা এণ্ডত ৰেষ্ট্ৰিক্টেড থাকে, both এণ্ডত কি থাকিব হেল্ড ইন পজিশ্যন, both এণ্ড হেল্ড ইন পজিশ্যন, বাকী ওৱান এণ্ড ৰেষ্ট্ৰিকশ্যন, ওৱান এণ্ডত কি কৰিছোঁ ৰেষ্ট্ৰিকশ্যন দিছোঁ, এগেইন ৰ'টেশ্যন, ডেট ইজ 0.8L। আৰু both এণ্ড হেল্ড ইন পজিশ্যন আৰু both এণ্ড হেল্ড ইন পজিশ্যন আৰু both এণ্ডত কি কৰা হৈছে ৰেষ্ট্ৰিকশ্যন দিয়া আছে ৰ'টেশ্যনত, তেতিয়াহ'লে কি হ'ব 0.65L। আৰু both এণ্ড হেল্ড ইন পজিশ্যন আৰু both এণ্ডত কি কৰা আছে আৰু ৰেষ্ট্ৰিকশ্যনত কি দিয়া আৰু নট ৰেষ্টেণ্ড ইন ডিৰেকশ্যন, আৰু কি দিয়া আছে ৰ'টেশ্যনত কি দিয়া আছে ৰেষ্টেণ্ড দিয়া নাই, ৰেষ্ট্ৰিকশ্যন দিয়া নাই। যদি ৰেষ্ট্ৰিকশ্যন দিয়া নাই ৰ'টেশ্যনত তেতিয়াহ'লে তাৰ ভেলুটো কিমান হ'ব similar L, okay, same length of the initial column, okay. So coming to the next question, as per the IS 800 for compression flames, the outstand of flange plates should not exceed 16 thickness, right? Thickness 16 into T, right? So here outstand of flames মানে the distance between the wave and the outermost edge of the flange plate, right? মানে ওয়েভৰ পৰা, so if this is our wave, so ওয়েভৰ পৰা outermost edge, okay, outermost edge of the flange, these are flange, right? So outermost edge পৰা আমাৰ ওয়েভৰ মাজৰ যে ডিসটেন্স সেইটো কি বুলি কওঁ আমি outstand of flange plate, right? So this value should not exceed 16 of T, right? Here T is the thickness of the thinnest flange plate, okay. আমাৰ যেটো thinnest যেটো প্লেট থাকিব তাৰে থিকনেছতকে 16 টাইমতকে বেছি হ'ব নোৱাৰে, right? So coming to the next question, the magnetic bearing of a line AB is S45E. So let us do a diagram. So the question is given, so it is our suppose this is our magnetic node, 2 node. Now the declination is 5 degree west, magnetic bearing given as S45 degree. So this is our magnetic node, okay. So magnetic node kiman dia ase S45 degree E, right? So S45 degree E hole, suppose this is our S45 degree E, S45 degree E, okay. So here since declination is west, right? So minus 5 degree, okay. So minus 5 degree hole kiman hobo S45 degree east minus 5 degree, okay. That is our S45 degree west, okay. So the answer will be S45 degree, S40 degree west, S40 degree east, right? Coming to the next question, so the declination, if the declination যদি declination যদি ওয়েস্টত থাকে তাহলে মাইনাসত ল'ব লাগিব, আৰু যদি declination যদি প্লাসত থাকে তাহলে আমি declination যদি ইষ্টত থাকে তাহলে আমি প্লাস লম, okay. You can also calculate by this directly, or also you can also calculate by diagram also, okay. You can also calculate the diagram also, because if you can also apply another approach also, okay. Let me explain. So this is our magnetic node, right? So here is the line, there is a line, okay. So from here to here was 90 plus 45 degree, right? So that is our 135 degree, okay. From here to here on 35 degree, but we need to calculate, we should have calculated this angle, right? So it will be 5 degree minus, right? So that is our 130 degree, okay. if you want to calculate in reduced bearing, then it will be 40 degree. Okay, you can also calculate by this approach also. So coming to the next question, the effective length of a coulomb of length L fixed against rotation and translation. So fixed against rotation and translation means the one end is totally fixed. Okay, one end is totally fixed, and one end totally fixed and another end is free. Okay, so the answer is 2L, right? So if the one end fixed and the another end is free, that is our twice L. Surface tension is due to the surface tension is due to the fact of cohesion only. Okay, but here another one is capillarity due to adhesion and cohesion. Okay, but here surface tension is only due to the cohesional force. What is cohesional force? Cohesional force is the force of attraction between the molecules, right? Same molecules. So it is the most appropriate to say that uniform flow in an open channel flow occurs when there is a balance between. So what is uniform flow? Uniform flow is the flow that যেটো ফ্লোত কি হয় আমার ফ্লুইডৰ প্রপার্টি কি হয়, চেঞ্জ নহয়। ফ্লুইডৰ প্রপার্টি চেঞ্জ নহয় উইথ রেসপেক্ট টু স্পেস। ওকে, with respect to point or space or given location or with respect to location, fluid property চেঞ্জ নহয়। fluid property যেনেকুৱা density, velocity, okay, discharge, these things are not changing with respect to place. That is called our uniform flow. এতিয়া ইউনিফর্ম ফ্লোত কোনটো বেছৰ সেম থাকিলে এই বস্তুখিনি চেঞ্জ নহ'ব। যদি আমাৰ হেৰি গ্ৰাভিটেশনাল ফোর্স যেটো ফোর্সে কি কৰে, যেটো ফোর্সে ফ্লোটোক ডমিনেট কৰি আছে, যেটো ফোর্সে ফ্লোটো পুল কৰি আছে, দ্যাট ইজ আৱাৰ গ্ৰাভিটি ফোর্স, ৰাইট? গ্ৰাভিটি ফোর্স এণ্ড গ্ৰাভিটেশন ফ্ৰিকশনাল ফোর্স যদি নাথাকে, এই দুটা ফোর্স যদি সেম হয় বা এই দুটা ফোর্স যদি মাজত যদি বেলেঞ্চ থাকে, তেতিয়াহ'লে কি হ'ব আমাৰ তার মানে কি আমার ক্রস সেকশন আমার যেটো চ্যানেলৰ যোনটো চ্যানেল দিয়ে আমার ওয়াটারটো ফ্লো হৈ আছে, চ্যানেলৰ ক্রস সেকশনটো সেম আছে। তার মানে চ্যানেলৰ ক্রস সেকশনটো যদি সেম নহয়, তেতিয়াহ'লে কি হ'ব, ফ্রিকশনাল ফোর্স এণ্ড গ্রাভিটি ফোর্সৰ বেলেঞ্চ নাথাকিব, রাইট? সো চ্যানেলৰ ক্রস সেকশন, চ্যানেলৰ বিহেভিয়ার, স্লোপ, এইবিলাক বস্তু যদি সেম থাকে, তেতিয়াহ'লে তার মানে ফ্রিকশনাল ফোর্স এণ্ড গ্রাভিটি ফোর্স আর ইন কনস্ট্যান্ট। ওকে, so if these things are not changing, the cross section slope of the channel, if these things are constant, then the gravity and frictional force will be in the balance, right? So if these things are balanced in, then it will give uniform flow of motion, right? So option A is the correct answer. Coming to the next question, standard size of brick as per Bureau of Indian Standard BSI, that is our 190 into 190 into 90 mm, right? One thing to be remember here, that is our fork size. So fork size is what is fork size? Fork is the this is fork, right? So what is the size, standard size of fork? So standard size of fork is that is our 100 by 40 and height is 10. Okay, so 100 means 100 mm, 40 mm and 10 mm. Okay, this is the standard size of fork. So fork is the depression that is provided on the top of the brick to form a key for mortar, right? To make a good bond between mortar and brick, right? So coming to the next question, cement concrete has tendency to be সিমেন্ট কনক্রিটের কি থাকে, টেন্ডেন্সি থাকে পরাস হওয়ার একটা টেন্ডেন্সি থাকে, রাইট? বাট যদি আমি কিউরিংটো ভালকৈ কৰোঁ, তেতিয়াহ'লে কি হ'ব, পরাস হওয়ার পসিবিলিটিটো নাইকিয়া হৈ যায়, রাইট? সো কিউরিং এখানে মিনিমাম 7 days কিউরিং কৰিব লাগে, রাইট? 7 days, ওকে, নট 7 days, মিনিমাম 10 days কৰিব লাগে, মিনিমাম 10 days, ওকে। যদি 28 days যদি কিউরিং কৰা যায়, তেতিয়াহ'লে কি হ'ব, যেটো স্ট্রেংথটো ডাবল হৈ যাব, ওকে, 2 times হৈ যাব। সো দ্যাট ইজ ভেরি ইম্পর্টেন্ট, ওকে। সো আজিৰ কাৰণে এইখিনি, বাকি 25 কুৱেশ্যন নেক্সট ভিডিঅ'ত আপলোড দি দিম, ওকে। যদি ভিডিঅ'টো ভাল লাগে তাহলে লাইক, শেয়াৰ এণ্ড কমেণ্ট কৰিব আৰু পাৰিলে শ্বেয়াৰ কৰিব। থেংক ইউ।